Hello everyone and welcome back. Welcome back. Root Beer here with question number 20 on the Pascal paper we've been going through for the last little bit. That's the 2009 Pascal contest. It's never too late to print out a copy and practice it for yourself, so I do encourage you to do so. We're up to question 20 now. But of course, if you want to try question 20, pause the video, go right ahead, and then come back if you want to compare your answer with mine. Different positive integers can be written in the 8 empty circles. This reminds me of, I think it was a Fryer paper or a Galois paper from very early on. I want to say 2006, 2007, doesn't matter. But different positive integers can be written in the 8 empty circles so that the product of any 3 integers in a straight line is 3,240. What is the largest possible sum of the 8 numbers surrounding 45? Okay. Interesting. Interesting. So the numbers in a row are going to have to multiply to 3,240. Well, that 45 in the middle is certainly taking up a great deal of these factors. I think we had, we have 8. So place this top one a little more northernly. There we go. Maybe make these a little bit bigger. So that 45 is taking up a fair bit. So what's left? 3,240 divided by 45 beats me. So grab my calculator. 72. Okay, now, did they say, so different positive integers? Because otherwise I could just say, well, 72, 1, 72, 1, 72, 1, just have a whole bunch of numbers there, and that would be great. But we want different positive integers. So, well, we should probably take a look. So, if I've got two opposite things, A, B, C, D, these all have to be different positive integers that are factors of 72. So AB is 72, CD is 72, and so on. EF and GH. So these are all 72. So it might be a good idea to list out the factors of 72 in pairs. So the factors of 72, I won't say 72 equals, I'll say well, we can get 1 and 72. We could have 2 and 36. We could have 3 and 24. We could have 4 and 18. I can't have a factor of 5. Can have a factor of 6. That'll be 6 and 12. 8 and 9 are the next ones because you can't have a factor of 7. And that about does it. So in terms of pairs, we've got 1, 2, 3, 4, 5, 6 pairs. We only need 4. We need 4 different pairs. So, well, we want the biggest sum. We could go through. We could make a little chart saying, well, what's the biggest sums out of all of these? But if you think about it for a moment or two, you're going to realize that the 4 biggest sums are going to come from having these 4 biggest numbers here. And the smaller numbers don't really contribute a whole lot. But if you want to, 1 and 72 is 73. 2 and 36 is 38. 3 and 24 is 27. 4 and 18 is 22. 6 and 12 is 18. And then we get 17. So the closer the numbers get, the smaller their sum. Okay, which is a nice property. It comes up on contests every once in a while. I think it was popular in this year's Gauss as well. Talking about multiplying numbers and trying to get... not multiplying numbers to the same amount, but trying to get the biggest sum possible. But, okay, fine. So what are our numbers going to be? Well, we're going to have pairs 1, 72, 2, 36, 3, 24, and 4, 18. And so what do these all add up to? 73, 38, 27, 22. 73 and 27 add up to 100. 38 and 22 add up to 60. So we should get Oops, that's a 60, not a 66. So we should get 160 is the best possible answer. And 160 is right there. It's right below, it's the second highest number, 211. And I strongly suspect that 211 is there so people don't just say, oh, they're looking for the largest number, I'll just guess the largest number. Oftentimes that's not what's going to happen. You know, every once in a while it does happen to be the largest number. But it's usually second or third largest number that they have presented. Just because they don't want people guessing. And they don't want the people who've figured out the pattern that it's never the largest number to not just say, well, the second largest number is the one we work with. We actually should reason our way through it. And it wasn't so bad. Figured out the 72, got the factors, picked the 4 factors that were biggest, because each pair of factors in total will have 8 numbers to fill in these 8 circles, and we wanted different positive integers. So 160, and that's an answer of E. So let's just quickly write that down. And we're going to move right along to question number 21, and I will see you for that in the next video. Take care.